Hi, this is Terry, and I've created this video tutorial on the time value of money because we all thoroughly enjoy money, right? Probably the first concept that we need to look at is the difference between simple and compound interest. And with simple interest, such as a short-term note to the bank, what you're working with is principal times rate times time is going to be your interest. So you would pay back to the bank the original amount that you borrowed plus that interest. The concept of compound interest is used in pension funds, or if you study bonds, look at long-term liabilities. They use compound interest. And if we slide down here to our graph here, let me slide our little project down, our little graph down. The simple interest then is just that principal times rate times time. When we talk about compound interest, then it grows because the interest is growing interest. So for example, with compound interest, if you put $100 into an account and your interest rate is 8%, that at the end of the first year, you'd have $8 in interest, so the running value at the end of the first year would be $108. At the end of the second year, then, at 8% interest, not only would you get another $8, but you get an additional 64 cents, 116.64, because that 64 cents represents interest on the interest, and hence the word compound interest. Let me slide down a little bit more here, and we'll go to a timeline. And I think timelines are one of the easiest ways to show what's going on. When we are interested in the present value, oftentimes what we'll do is we'll put money into an account today, and what we're interested in is what does that future value become. So we'll see here in a minute our calculations and formulas and tables, etc., on how to create that future value. But the concept is we put money in today, what is it going to be worth in the future? The present value is the reverse, that we know what dollar amount that we need in the future, and what we want to know is how much money must we put into an account today so it will reach that value. So the very first thing that you want to do is to decide in any situation, is it a present value or a future value concept. So again, let's slide down a little more here. And one of the first things I guess to look at is how do they come up with these formulas so you can make those calculations. So if we use the timeline and say, okay, at time 0 we're going to deposit $1, then the formula to show the growth would be 1 plus I to the first power. So if we use, let's say we're going to use a 10% interest rate, then this would be 1 plus 0.10 raised to the first power. So that would be the growth times the previous amount. When we get into the second period, the growth factor is going to be 1 plus I to the n, or to the first power, times the previous amount, which was already 1 plus I. So 1 plus I times 1 plus I gives us 1 plus I squared. Similar, in the third period, the growth factor is going to be 1 plus I times the previous amount. Therefore, 1 plus I times the previous amount, which was already 1 plus I squared, becomes 1 plus I cubed. So you can see for any given future value, you can take the present value times 1 plus I to the nth power. So you'd pop in your interest rate here of I being maybe 10%, and then the number of periods. Let's just say, for example, it's 5 periods. Then you'd have 1.10 raised to the 5th power. So 1.10 raised to the 5th power times the present value. What you have to remember is all these formulas are based on a single dollar. So that's why we have to multiply it times the present value. Let's move on down a little bit lower, and we'll see this in practice here. So at this point, contractor calls for a deposit at time 0 for $100,000. And then you have to put that money into an account. It's going to grow at 10% interest for 4 years. And the question is, what is this going to grow to? So in other words, what we're interested in is what is the future value. Well, we just got done saying the future value equals the present value times 1 plus I to the nth power. So this would become the future value equals $100,000 times 1 plus the interest rate of 10% raised to the 4th power. All right. Let's move on down then. An easier way to look at this, then, is to look at these tables where this is already calculated. So a present value table has that 1 plus I to the n already calculated for you. So the n's become period 1, 2, 3, 4, 5, 6, 7. The interest rates go across the top. The periods are going down to the bottom. So interest rate across the top, periods across the side. So in our example here, we needed 10% for 4 periods. We get 1.484. So if we take $100,000 times 1.484, then that future value is going to be $148,400. Okay? One thing that we should kind of point out here is these formulas are all based on an annual rate. So if your problem is set up that you're going to compound semi-annually, then our 10% interest rate we have to divide by 2 because semi-annual means 2 compounding periods. And then the number of periods, which is 4, n has to be multiplied times 2. And now you've just converted from an annual rate to a semi-annual. Likewise, you do the same with quarterly or monthly. If it's monthly, you'd have to divide the interest rate by 12 and multiply the number of periods times 12 to bring it to a monthly calculation. Let's slide down now to the present value, which is just a way of rewriting our formula. Our future value equaled our present value times the factor. If we take both sides and divide it by the factor, then in the numerator and the denominator cancels out. We've just isolated the present value is equal to the future value divided by 1 plus I to the n. So let's see this in action. If a business had to pay out $100,000 at the end of 4 years, then how much would it have to deposit in a bank account today? So what we're interested in here is at time 0, we need $100,000, or we're going to pay $100,000 4 years from now. The question is, how much money must we deposit today, one time, for it to grow to that amount? So again, if we go to our present value tables here instead of our future value table, then we have 10% for 4 periods. We come over here and it's 0.683. So 0.683 times $100,000 is going to be $68,300 if I looked at my table correctly. So in other words, if we deposit $68,300 today and let that compound at 10% for 4 periods, then we'll have that $100,000 that we need 4 years from now. Sometimes then, when we move into our third concept here, our third concept is the concept of an annuity. And the annuity is different from the present value and future value of a dollar because present value and future value of a dollar are about a one-time payment. What we're interested in here is what happens if we deposit that money every year for a given number of years. So if you were going to put in $10,000 a year, 10,000, 10,000, 10,000, 10,000, 10,000, then what we could look at is, of this money, we could look at what's the present value of that annuity, or what is the future value of that annuity. The formulas get quite complicated, so we have the formulas written out here for you. It's just easier, if you don't know how to use your calculator, is to go ahead and just use the tables here. So let's go through an example, and then we'll use the table so that this will make a little more sense. A contractor called for the deposit of $100,000 at the end of each year for 4 years. So including the compound interest, what amount will accumulate at the end of the time period? So the first question is this a present value or a future value? And hopefully what you recognize is this is a future value problem, because they want to know how much it's going to accumulate to. So we've got a 10% interest rate, 4 years. We go down to our tables here. We look at 10% interest rate for 4 years, and that becomes 4.841. So if we take our 4.481, the $100,000, times 4.841, then that is going to accumulate to $484,100. So if we put in $100,000 every year for 4 years, the checkbook value will be $100,000 every year for 4 years, but the $84,100 represents the compound interest. So if we want to know what it's going to be, $100,000 every year for 4 years, it's going to grow to $484,100. Alternatively, what we can do is kind of do this in reverse. Is what if a business had to pay out $100,000 every year for 4 years? How much would you have to put into a bank account today? And there's your key word to let you know that this is the present value, and it's an annuity because it's every year for 4 years. So we go to our table of 10% for 4 periods. We see 3.170. So 3.170 times, 3.170 times the $100,000, then the answer is that we would have to put $31,700 into a bank account. All right. Excuse me, when I turned around and said $31,000, that's not correct. It's $100,000 times the factor of 3.170. Oops, and I just lost everything. So let me arrow back down to where I was. Okay, so if we go back and look at our factor, 10% for 4 years, it's 3.170. $100,000 times 3.170 is $317,000, which is what I should have said. So if we deposit $317,000 into a bank account today, then what we can do is pull out $100,000 every year for 4 years, and the amount of money that's in there, whatever's left over, will be gaining interest. Alrighty, if we move down just to the last part here, then I always like to point out to students the difference between the checkbook amount, the present value, and the future value. So if we wrote checks for $10,000 every year for 5 years, we would be writing checks for $50,000. But the issue becomes, since this amount of money is out in time, this is first year, second, third, fourth, and fifth year, and we're bringing these back to its present value, that's what our tables were about, then we're going to have less than $50,000 even though we're writing checks for $50,000. If we go the other route and look at the future value, then this first deposit is going to gain interest for 4 years, the second deposit for 3, the third deposit for 2, the fourth deposit for 1 year, and then make that final fifth deposit. It's going to be greater than $50,000. So a present value will be less than $50,000. A future value will be greater than $50,000, even though we're writing checks for $10,000 every year for 5 years. That's $50,000. And that's the whole concept that we're trying to accomplish here, is that when we think about how money is spent, especially when we get to capital budgeting, the emphasis is not on what we write the checks, but what is that money worth today, what is that money worth in the future, all based on compound interest. There's two more concepts that I want to make sure that you understand. So I'm going to slide back up to the top here to my timeline. The first concept is that if we have the present value and the future value, let me get rid of that little toolbar in the way here. You may not be able to see that. Sorry. The concept is, if we have $1 today and we have $1 a year from now, which is more valuable? And the answer is $1 today is worth $1, but $1 a year from now is actually worth less than $1 because we can put it into a bank account and let it draw interest. So if we have $1 3 years from now, that's worth less even more, and $1 5 years from now is worth even less than that. And the concept is, because we can put a lot smaller amount of money into a bank account and let it draw interest. So if we look at the table here, if I slide down here to our tables, and I want the present value of $1. If we start out, and let's say that we're going to have $1,000, and we've got that at time 0. Well, in one period, and let's just use 10% here, these factors, then what we're seeing is we could put $909 into a bank account and in today's money and let it grow at 10% interest, and it will become $1,000. If we put in $826 into a bank account but let it draw interest for 2 years, then it becomes $1,000. If we put $621 into a bank account today and let it grow for 5 periods, then it becomes $1,000. So the further out in time that this $1,000 goes, first period, second period, third period, the further out in time you go, then the less that money is worth. So if you look at your tables, you'll see that as time goes by, these numbers all get smaller as you go down. Also, they get smaller as you go across because you're compounding at a higher interest rate. So therefore, the higher interest rate that you compound at, the less amount of money you need to start with. So the ultimate goal in any pension fund or long-term investment is for you to start out with the least amount of money and have it to grow to the largest amount of money. Is you want the highest interest rate and the longest possible time. So the best scenario is invest at a very early age at a very high interest rate, and you'll have lots of money when you go to retire.